Let's take a look at problem 140 from section 1.5. This is an application problem, and let's have a look at it. A rectangular park is 6 miles long and 3 miles wide. How long is a pedestrian route that runs diagonally across the park? Well, the first thing we'll do is draw a sketch of the problem. So we know that the park is rectangular. We know one side is 6 miles long and the other side is 3 miles long. And then the route that we're trying to find the length of runs diagonally through the park. So the picture looks something like this. We don't know and are trying to find the length of the pedestrian route. And so we want to use Pythagorean's theorem. So Pythagorean's theorem tells us that a squared plus b squared equals c squared. So in our particular problem, it doesn't matter which side we call A or which side we call B. So let's call the side that's 6 miles long A and the side that's 3 miles long B. And then obviously the C is our x. So 6 squared plus 3 squared equals 2x squared. 36 plus 9 equals x squared. 45 equals x squared. So this problem is a perfect candidate for solving using the square root property. So let's apply that to this problem. And if the square root property tells us if x squared is 45, then x is plus or minus the square root of 45. And we always want to simplify our radicals. So 45 is not a perfect square, but it does contain a factor of 9, which is. So we'll rewrite the radical as plus or minus square root of 9 times the square root of 5, which simplifies to plus or minus 3 times the square root of 5. Now, notice that only the positive value makes sense for the problem. So when you're doing applications, you may get a number of solutions, but many times only one or some of them make sense given the nature of the problem. So in this case, only the positive result makes sense. So our conclusion then is that the pedestrian route is 3 times the square root of 5 miles long. So now let's take a look at problem 150, where a vacant rectangular lot is being turned into a community vegetable garden measuring 15 meters by 12 meters. A path of uniform width is to surround the garden as shown in the figure. If the area of the garden and path combined is 378 square meters, find the width of the path. So this new larger rectangle has a longest side that's x plus 15 meters plus another x. So let's write 2 x's plus 15. So when we look at the length of the longest side, we've got x plus 15 meters plus another value of x. So we'll write that as 2x plus 15. The shorter side of this larger rectangle is x plus 12 plus x meters. long, which is 2x plus 12 meters long. And we're told that this area is 378 square meters total. So to find area of a rectangle, we take the length of one side, 2x plus 15, and multiply that by the length of the other side, 2x plus 12. And this length times width gives us our 378 square meters. So in order to solve this, we've got to compute the product 2x plus 15 times 2x plus 12. And we're going to use the distributive property twice. So we've got to multiply 2x times 2x plus 12. And we also have to add to that 15 times 2x plus 12. And that needs to equal the 378 square meters. So let's use the distributive property twice here. 2x times 2x gives me 4x squared. 2x times 12 gives me 24x. Plus 15 times 2x is 30x. Plus 15 times 12 is 180. And that equals to 378. All right, so let's combine the like terms. 4x squared plus 54x. And let's subtract 180 from both sides of the equation. We'll solve this one by using the square root property, just to get a little bit of practice with that. So 4x squared plus 54x will equal 198. So the square root property says if a, the coefficient of x squared, is not 1, divide every term of the equation by a. So we're going to divide every term by 4. So this equals 729 over 16. So that's what we're going to add to both sides of the equation. So x squared plus 27 over 2x plus 729 over 16 equals 99 over 2 plus 729 over 16. So in order to add the 99 over 2 to the 729 over 16, I need to have common denominators. So I am going to multiply the numerator and denominator of 99 over 2 by 8. And that will not change the value of the fraction, but rewrite it with the same value as a fraction that has a denominator of 16, which is what I need in order to add this to 729 over 16. So So this becomes 792 over 16. And I'm going to add that to 729 over 16. And what typically is a good thing to do with the left side when you add that constant on is to leave that constant in its form as a perfect square. So I'm actually going to leave 729 over 16 as 27 over 4 squared. So I'm going to put that in that format. And you'll see why I am doing that in a moment. All right, so let's continue with this. And let's look at factoring the left side of this equation, since this is now a perfect square trinomial. So this factors into x plus 27 over 4, that quantity squared. So now perhaps you can see why I left it in the form of the square of 27 over 4. So this, on the right side, combines to give 1,521 over 16. So you can see the square root property is now what we are able to use. If the square of x plus 27 over 4 equals to this expression on the right, then x plus 27 over 4 equals plus or minus the square root of 1,521 over 16. And so let's continue by subtracting or adding a negative 27 over 4 to both sides. So x is equal to negative 27 over 4 plus or minus.
Oh, you went to the doctor, right?
So the square root of 1,521 is 39, and the square root of 16 is 4. So x is actually equal to negative 27 over 4 plus 39 over 4, which would be 12 over 4, which equals 3, or x is negative 27 minus 39 over 4, which would be negative 66 over 4, which doesn't make sense for the problem. This is actually not applicable. Since x represents the width of the path around the garden, it doesn't make sense to say that x is a negative number. So we wind up simply discarding that answer. And so the width of the path then has to be 3 meters. So the width of the path is 3 meters long. That's our final answer for this problem.